Let's look at the z-test and the t-test in hypothesis testing. So the first thing to have clear in our minds is when to use which. So the z-test is used to test a null hypothesis if the population variance is known or if the sample size is larger than 30. A t-test, on the other hand, is used when the sample size is less than 30 and the population variance is unknown. So the most common factor that you'll use to determine whether to use the z-test or t-test is generally the sample size. So when the sample size is larger or equal than 30, you'll generally use the z-test. And the t-test, on the other hand, when the sample size is generally less than 30, you'll use the t-test. Okay. But sometimes for the t-test, you'll also see that the population variance is unknown. Now let's look at this exercise then. A researcher is interested in finding out whether the average lifetime of females in the US is different from 75 years. For this, he takes a sample of 100 females with a sample mean of 76 and a sample standard deviation of 7. State the null and alternative hypotheses. At a 95% confidence level, is there enough evidence to reject the null hypotheses? So given what we said in the first slide, what do you think we're going to use here, a z-test or a t-test? So in this case, we are indeed going to use a z-test because the sample size, as you can see, is higher than 30. It's 100 to be more precise. So let's state the null and alternative hypotheses. So the null hypotheses and the alternative hypotheses. Now remember, what you need to do in order to determine what the null and alternative hypothesis is generally to understand that there's one thing that is generally accepted, and then someone is going to come in and challenge that accepted view, that traditional view. Okay. So in this case, for example, the challenge is the researcher. Okay, so the researcher is going to come in and challenge a traditional view by saying that the average lifetime of females is different from 75 years. Okay. So then we know that the null hypothesis is that generally we think that the average lifetime of females is 75 years. So mu is 75. But then this researcher comes in and tries to challenge this view by saying that no, it's actually different from 75 years. So it's different from 75 years. Okay? Right. Then we need to draw the distribution. Now in this exercise it says at a 95% confidence level, is there enough evidence to reject the null hypotheses? Okay. So what we need to do first is to draw the rejection regions. Okay. Now because this is a two-tailed test, and it's a two-tailed test because it can either be higher than 75 or lower. Okay. Which is why it's a two-tailed test and not a one-tailed test. So two-tailed test means it can be on either side. So we need to draw a shaded region on both sides. Okay. And this shaded region is going to be the rejection region. Okay. Now, the 95% is going to be inside. And then the rejection region is going to be what's left divided by 2. So here we have 5% left. We divide that by 2. And it gives us that the rejection area or the rejection region is 0.025 on both sides. Okay, so 2.5%. Excellent. And now we need to find out the critical values. These values are the values at which the rejection region starts. Okay, so we need to find the critical value here and one here. Okay, in order to do this, we need to look at this table, the Z table. Now the value you need in order to find out the Z value is this 0.025, okay? So this 0.025, we're gonna need to find inside this table and then look horizontally and vertically in order to find out the values. So let's look for 0.025. Now, as you might have seen, 0.025 is this value here. Okay. So what we need to do now is we need to go horizontally and also vertically. So the horizontal value minus 1.9, and then on top we have the decimal places. So in this case we have 0.06. So what you want to do basically is minus 1.9 and then or 1.9 and you add 0.06. So this becomes minus 1.96. Okay. So this plus or minus 1.96, by the way, this can be used either for minus or for plus, it's the same thing. So this is going to be our critical values. So if we look back, we use the positive critical value on the right hand side and then the negative critical value on the left hand side. Okay, so now we have our critical value. And now, in order to know whether we can reject the null hypotheses, we need to find out the Z value and then see whether it falls inside the rejection region or outside the rejection region. If it falls inside the rejection region, we reject HO. If not, we fail to reject HO. Okay, so let's find this Z value. Now, as you can see, here is the formula for it. But before we use this formula, let's write down what we know. So we know that the sample size is 100. We know the sample mean is 76. And the sample standard deviation, S, is 7. Okay. And this element here is the hypothesized mean. Okay. And this hypothesized mean is basically this value. Okay. The 75. So then we use the formula. So the Z value is the sample mean, 76, minus the hypothesized mean, 75, over the sample standard deviation, 7, divided by the square root of the sample size. And if you plug this into your calculator, you should get approximately 1.43. Now, as you can see, 1.43 falls outside the rejection region. It falls, I don't know, about here, let's say, 1.43. So this means that we fail to reject HO. Okay? And if we put it into words, this means that the average lifetime of females isn't different from 75. Okay? It's actually 75. Very good. What about this exercise? A researcher is interested in finding out whether the average regular gasoline price is higher than $2.45 in Midwest region. The sample analyzed consists of 25 observations, a sample mean of 2.65, and a sample standard deviation of $0.35. State the null and alternative hypotheses. And B, at a 99% confidence level, is there enough evidence to discard the null hypotheses? So what do you think? Do we need to use the Z-test or the T-test in this case? Now for this exercise, we indeed need to use the T-test. And this is because the sample size is less than 25. Okay. So let's take the null and alternative hypotheses. So again, we have a traditional view, a view that we always accepted, and then someone challenges that. So as you can see, here a researcher challenges a view and says that the average regular gasoline price is higher than 2.45. So the null hypothesis must be that the gasoline price is 2.45. Okay. And then he challenges the view by saying that it's actually higher than 2.45. So higher than 2.45. Okay. Now let's draw the distribution. As you'll notice from this, the alternative hypothesis says higher, okay? It doesn't say different from. So in this case, it can only be higher. So we know that this is going to be a one-tail test, okay? But on which side? Is it going to be the right side or the left side? Now, when it's higher, it's going to be on the right, okay? And when it's lower, it's going to be on the left, okay? Very good. So then again, this is the rejection region. So if the t value falls into that, we reject HO, and then the rest is the confidence level, okay? And so this rejection region is what's left over, so 0.01. Okay. And now we need to find again the critical value. Okay, so the value at which the rejection region starts. Now for the t-test, we need to use this table, which is slightly different. Okay. So again, here we have the alpha, which is our significance level, which in our case is 0.01, like we said. And then we have the degrees of freedom here. Now, in order to calculate the degrees of freedom, the formula is n minus 1. So in our case, the sample size is 25. So we do 25 minus 1, which is equal to 24. So these are our degrees of freedom. So we go down on the degrees of freedom, down to 24, which is about here. And then we need to look up at our significance level, 0.01. And then we get the value where both of these meet. So we go like this, horizontally. And then same thing for the significance level. And so we get this value, which is approximately 2.49. Okay. Very good. So this is our critical value. And by the way, this can be negative or positive. Okay. You choose which one is better for your exercise. So in this case, we need the positive one. So our value is 2.49. This is our critical value. Excellent. And now we need to find out the t value and see if we can reject the null hypothesis. But before that, let's write down what we know. So the sample size we said is 25. The sample mean is 2.65. And the sample standard deviation is 0.35. So then we plug all these numbers into the formula. So 2.65 minus 2.45, the hypothesized mean, remember, over the sample standard deviation, 0.35, over the square root of n, which is 25. And if you plug this in the calculator, it should give you approximately 2.86. Now, as you can see, 2.86 is indeed inside the rejection region. Okay? Which means that we reject HO. Okay? And in other words, the price is indeed higher than 2.45. Let me know down in the comments if you have any questions on this. I'll be happy to answer them.